Hey everyone! So, in this video we are going to talk about matrix determinants. So, the question of course is, what is a determinant? Well, it's just a number that's associated with a square matrix. So every square matrix has a determinant. Alright? And what is this determinant thing? It's just a number, like -5, 10, 48, 0. It's just a number. And why do we care? Because it's useful for doing things like matrix inversion, which we'll talk about in a later video. It's also useful for solving systems of equations. How do we write it? We use these bars. We put a single vertical bar on either side of the name of our matrix, right? So if our matrix is A, we do bar A bar, all right? But I want to be very clear. This is not absolute value. All right, this notation has nothing to do with the absolute value notation that we're used to. It looks the same, but that's where the similarities stop. Okay, so a matrix determinant is allowed to be negative. All right, just because it looks like absolute value, it's not. So let's look at how we actually calculate these. So if we have this matrix A, which is consisting of the elements A, B, C, and D. We calculate it by first going down the main diagonal, AD, and then we subtract the off diagonal, BC. So we do AD minus BC. And that's the determinant of A. 2 by 2 is really simple. Alright? 3 by 3 is a little bit harder. But it's still totally doable. If we have this matrix A, B, C, D, E, F, G, H, I. Alright, how do we calculate it? What we do is we take the first row, and technically there's other ways to do this, but this is the way we're going to do it. You take the first row, and for each element, A, B, and C, you find the determinant of the 2 by 2 matrix that doesn't have that column in it. So like for A, we're going to find the determinant of E, F, H, I. For B, we find the determinant of D, F, G, I. And for C, we find the determinant of D, E, G, H. And then, once we have those three, we multiply them by A, B, C, and we subtract the middle one. So it's A, the first one, times this determinant EI minus FH. Then we subtract B times DI minus FG. Then we add again C times DH minus EG. Okay? Why? It doesn't matter. Alright? Just know that that's what we do. That's how we do it. For a 4x4 and larger, I suggest you use a computer. It is possible to learn how to do that. It's not necessarily difficult. I just think it's more time consuming than it's generally worth, unless your teacher or instructor tells you that you need to know how to do it, in which case go learn. There's plenty of other resources for learning how to do that. I didn't want to spend focus on that because it gets needlessly complicated. But let's make sure that we know how to do 2 by 2s and 3 by 3s, and let's do that by looking at some examples. So I have here 3 examples. I encourage you to pause the video, try to work these out for yourself before we go on and talk through it together. I'll give you a sec. Alright, so let's start with matrix A. Right? Matrix A, 3, 5, 1, 4. How do we do it? 3 times 4 minus 1 times 5. And so that's going to be 12 minus 5, 7. Did you get it right? I hope so. Let's look at now matrix B. Right? Diagonal, 2 times 4 minus 5 times 3. So 8 minus 15 is -7. See? Those aren't so bad. Now let's look at C. C is a little bit more complicated, but we do the first one times 5 times 9 minus 8 times 6 minus 2 times 4 times 9 minus 7 times 6 plus 3 times 4 times 8 minus 7 times 5. Right? So we start to simplify that. We simplify it a little further. We keep going, and we actually get down to a determinant of 0. The determinant of matrix C is 0. That's okay. That happens. All right? That's allowed. It's just a determinant is just a number. Okay? So there you go. You are now an expert on 2x2 and 3x3 determinants. Congratulations. So thank you for watching, and we'll see you next time to learn how we can use determinants for something other than just calculating them in and of themselves. See you later.